Hi guys, good night everybody. Um, just let me know if you guys can hear me before we start, please. All right, great. All right. So I had a little time, right? So I decided to come on live for you guys, right? Just keep in mind this is not. I'm not going to cover the entire syllabus or anything like that, right? My actual crash course was about 2 Saturdays ago, right? Um, So tomorrow is the advanced paper 2, right? As you all know the structure of the exam, you have 6 questions to do, right? And the first question typically will be things like remainder theorem. It'll be things like um, quadratics. They love to bring quadratics, right? Now the questions that can gain you some marks here, right, is question 4 in the exam and question 5. Question 4 is on differentiation and question 5 is on integration. Those two questions are questions that we can kind of predict what's going to come in the exam, right? Um, so I'm going to run through one or two things that typically come a lot in the exam, right, that you need to be familiar with. So when it comes to differentiation, right, there are a few formulas we need to know for differentiation. So for example, if we have x to the power n and you want to differentiate this, right, this is going to be n x to the power n minus 1, right? So when I differentiate, let's say something like x to the power 4, when I differentiate this, I'm going to get 4x cubed, right? So that's basic differentiation that we need to be familiar with. If you differentiate a constant, right, once you differentiate a constant, you're going to get 0. So if you were to differentiate something like 6, you're going to get 0, right? If we have something like ax to the power n and you want to differentiate this, right, this is going to be n ax to the n minus 1. So for example, if you had, let's say, 4x cubed and you differentiate this, what you're going to get 12x squared, right? So this is basic differentiation that we all should be familiar with, right? Also, if you differentiate sine x, you're going to get cosine x, right? We also need to know what happens when we differentiate sine ax as well. If you differentiate sine ax, you're going to get a cosine ax, right? So we need to be familiar with these equations, right? We also need to be familiar with cosine. If I differentiate cosine, you're going to get negative sine x, right? Some of these formulas are given to you in the exam, not all of them are, so you need to remember these things. If we have cosine ax and we were to differentiate this, right, this is going to be minus a cosine ax, right? So these are some basic differentiation formulas that we need to remember, right? Also, let me just get a blank sheet here. Right? Also, we need to be able to know if we have something like y is equal to ax plus b to the power n, and I wanted to find dy over dx. So if I were to differentiate this, right, you're going to get n multiplied by ax plus b to the power n minus 1, right? Now here's the problem, right? So CXC will kind of bring this question in a way that will confuse some students. So if I have to differentiate this here, let's say I have something like 4x plus 1 cubed, and I wanted to differentiate this, right? Yes, I could use this formula here to work this out, right? If I had something like y is equal to, let's say, 2 minus 6x to the power 4, right? I could still use this formula in order to differentiate this, right? All I need to do is to write this as y is equal to minus 6x plus 2 to the power 4, right? This is something that CXC likes to bring, right? Because students don't realize that they can use that formula. Another common error that students make is this. They may see a question that looks like this: 3x squared plus 4, right? And let's say this is to the power 5. And there are some students who want to use this formula in order to work that out. I cannot use that formula to work this out because I have 3x squared plus 4 in bracket there, right? This has to be a linear form in order for me to be able to use that formula, right? So if you had to do a question like this, you're going to use function of a function in order to do that, right? So those are some of the basic formulas, right? For differentiation, these are the formulas that we need to know for the exam, right? Chances are these things could appear, right? And then we also have the quotient rule and the product rule as well, right? So let me just do one or two examples here, right? So these are all CSEC questions, by the way, right? So if I have to differentiate something like this, right? So this here, right? I can clearly see that this here is a function of x and this here is a function of x, right? Now there is a rule, right, that you all need to be familiar with. If I were to differentiate, right, and this here is the product rule. So if I have to differentiate a product, right, it is given by u dv dx, right, plus v du dx, right? So you all need to learn this formula, right? Make sure you know this. This is what we call the product rule. And you have to be able to identify two functions of x as a product. So if you wanted to differentiate this, d on dx, right? This is how you write it, by the way. Or you could put let y equal to what we have here and then find dy dx. That's another way you could write out your answer, right? Or we can just put d on dx and we'll put 2x squared plus 3, right? And this is sine 5x, right? So if you have to differentiate this, like I said, it's a product. This here is your u, this here is your v. You have to be able to identify functions of x as u and v, right? So you're going to take the first term, right? So let me just put a line here. You're going to take the first term, which is 2x squared plus 3, and you're going to multiply it by the differential of the second term, which is this. Now when you differentiate sine, you're going to get cosine. But if you have to differentiate sine 5x, it's going to be 5 cosine 5x, right? Plus, right? You're going to take the second term, which is sine 5x, and you're going to multiply by the differential of the first. When you differentiate the first term here, right? This is going to be 2 2s are 4. This is going to be 4x, right? So all I'm doing is applying my product rule here in order to differentiate this thing, right? Sometimes you can simplify. In this case here, I don't like to see the 5 in the middle here. So I'm going to put this as 5, open brackets, 2x squared plus 3, right? Cosine 5x, right? And we're going to write the 4x in front. So this is going to be plus 4x sine 5x, right? So what I'm using here, I'm using something called my product rule for differentiation, right? Right? All right, so this is product rule, right? We also have a quotient rule that you need to be familiar with as well, right? The quotient rule looks like this, right? So if I have something like y is equal to some function of x divided by some function of x as well, right? We can find dy dx, right? And dy dx is equal to the bottom, which is v, multiplied by the differential of the top, which is du dx, minus u dv dx all over v squared, right? So again, differentiation questions are very predictable, right? When it comes to CSEC and the AdMaths exam, very predictable, right? So if I want to differentiate this, right? So you want to differentiate d on dx, right? 3x plus 4 all over 2x minus 1. And you want to differentiate this. Clearly, this is a function of x. And clearly, this is a function of x here. So if you want to differentiate that, we're going to apply our rule here, which is this. So it's the bottom. So this is 2x minus 1, right? Multiplied by the differential of the top, When you differentiate 3x plus 4, you're going to get 3, right? And it's a subtraction, and it's the top, which in this case is 3x plus 4, multiplied by the differential of the bottom, which is 2, all over the bottom squared, which is 2x minus 1, all squared, right? Now again, you have to simplify this. Now, I see students making mistakes all the time when they're simplifying something like this. So you're going to write the 3 first, right? This one little step here is going to help you out a lot, right? Minus 2 by 3x plus 4 all over, right, 2x minus 1 squared, right? Now, why am I doing that? Because I continuously see students making mistakes when they're simplifying the top here. So you have to use the distributive law to remove the brackets. So 3 by 2x, then 3 by minus 1, 2 by 3x, and then minus 2 by 4 here, right? So when I simplify the top, I'm going to get 3 2s at 6x, right, minus 3. Then we have a minus 6x again. And then we have minus 2 by 4. You're going to get minus 8. And this is all over 2x minus 1 squared. Right? Now this answer is not done yet. Right? So the 6x and the 6x will cancel. So you'll end up with minus 3 minus 8. So this is going to work out to minus 11 all over 2x minus 1 squared. Right? So that's how we use our quotient rule. Right? Right? So this is some basic questions, product rule, quotient rule, right? Now another common thing that they bring in question 4 in the exam has to do with stationary points, right? So this question says find all the stationary points, right? Now, when it comes to a stationary point could be a maximum point. It could be a minimum point, right? It could also be something called a point of inflection, right? But that's not on your syllabus. So the ones that CSEC might bring will be maximum or minimum, right? Inflection is not on your syllabus, right? So the first thing you have to do when you want to find the stationary points in a curve, so we have a curve here given by x cubed, right, minus 5x squared, plus 3x, plus 1, right? So step 1, if you want to find any stationary point, or what we call a turning point as well, right, you need to find dy dx. We must differentiate this. When I differentiate x cubed, I'm going to get 3x squared. When I differentiate minus 5x squared, you're going to get minus 10x. And then when we differentiate 3x, we're going to get 3. And when you differentiate 1, you get 0, right? So this here represents my dy dx, right? Now you want stationary points. So you're going to see at a stationary point, right, dy dx is equal to 0. Right? So all you're going to do, you're going to put 3x squared minus 10x, right, plus 3 is equal to 0. Right? Now what does that do? So we're going to try to factorize this 3x squared, sorry. Right? So this here is going to be 3x multiplied by x. That'll give me 3x squared. If I put a 1 here and a 3 here, will that work? Yeah. So if I put a minus here and a minus here, right? So double check. 3x by x will give me 3x squared. Minus 1 by minus 3 will give me positive 3. That's minus 9x. Yeah, so this is correct here, right? That's correct here. So what does that do, right? What does that do for us? So we need to put each bracket equal to 0. So 3x minus 1 is equal to 0, right? 3x is equal to 1, and therefore x is equal to 1/3. Right? So that's one x coordinate of a stationary point. And the second one, we're going to put the second bracket equal to 0. So x minus 3 is equal to 0, and therefore x is equal to 3. Right? So what I've done here, I've just figured out where or what are the x values of those stationary points. Right? So in this case here, right, we need to figure out what are the y coordinates, right? Because we need to figure out what the points are on this thing, all right? So I need a blank slide here. Yeah, so we know x is 1/3 and y is equal to 3, right? So x is 1/3, right? So we need to figure out what y is. Now, some students, right, when they figure out what the x value is, they want to plug it back into this. No, you can't plug it back into that, right? That is not the equation of the curve. This is the equation of the curve, right? So we need to take that 1/3 and you're going to plug that into your original equation of the curve. So that's x cubed. Y is equal to x cubed minus 5x squared plus 3x plus 1, right? So in this case here, we're going to substitute. So this is going to be 1/3 cube, right, minus 5x squared, right? Those of you who have a calculator in front of you, just work this out for me quickly. Let's make sure we all have the same answer. Plus 3 by 1/3 plus 1, right? So work that out for me and tell me what you're getting for y. We're going to do the same thing for the second one, where x is equal to 3. Right, I've seen some of you all working it out. Let me work it out as well, right? So work out both of them for me, right? I'll tell you if I get it the same thing. Right, I've seen people getting 40 over 27. Yeah, I'm getting that same thing as well, right? 40 over 27, right? Now you can leave your answer like that if you want, right? So one stationary point here that I have is 1/3, right? And the second point here is 40 over 27, right? So that's one stationary point. For the next one, that is what, 27 minus 45 plus 9. Right? How much you all getting for the next one? I'm getting minus 8, right? Yeah, I'm getting minus 8 as well, right? All right, so this here is working out to be minus 8. So therefore, this point here is going to be 3 minus 8, right? Now, watch the process, you know. You differentiate it first. You put it equal to 0. You figure out what the x values are. Those are the x coordinates of the stationary points. You're going to take those x values, plug it into the original equation, right? And then you're going to use that now in order to figure out the points. Now the question says, right? And they only give us 3 marks for this, right? But they wanted the coordinates of all the stationary points. The next part here to determine the nature, typical exam question, right? When they ask you about the nature, about the points, what we need to do, we need to figure out whether it's a maximum or a minimum, right? To do that, what I'm going to do, I'm going to use what we call our second derivative. So if we have dy over dx, right, is equal to 3x squared minus 10x plus 3. 3x squared minus 10x plus 3. Right? First thing we need to do, we need to find our second derivative. In this case, it's d2y dx squared, right? So when I differentiate this, I'm going to get 6x minus 10. So this is what I'm going to use in order to determine the nature of the points, right? So let's write down the 2 coordinates, right? So if I were you, this is how I'll write up my answer. So 1/3 40 over 27. So 1/3 40 over 27. That's 1 point, right? So what you're going to do, right? So you're going to say when x is 1/3, right? You're going to find what the value of the second derivative is, which is d2y dx squared. So you're going to plug 1/3 into that formula there. So this is going to be 6 by 1/3 minus 10. Now we don't really care about the actual answer. What we care about is the sign of the answer, right? So 6 by 1/3 will give me 2. 2 minus 10 is going to give you minus 8, right? So could you all tell me, if I get minus 8 here, what does that tell me? Is that a maximum or a minimum? Right, people say maximum. Yeah, it is going to be a maximum. When it's negative, right, it's going to be a maximum, right? So you have to find your second derivative, and in this case is negative. So now we need to check the other point now. The other point was 3 minus 8, I think it was. Yeah, 3 minus 8. So we're going to substitute. So we're going to say when x is equal to 3, right, your second derivative, d2y dx squared, right, is equal to 6 multiplied by 3 minus 10. So that 6 3s are 18. 18 minus 10 is going to give me 8. So when that is positive, that is going to be a minimum, right? So this, like I said, this is a typical, they like to bring this. So make sure you all know how to determine the coordinates of stationary points, right? Typical exam question, right? All right. Ever so often they could bring a question on what we call connected rates of change, right? So we have a formula for the volume of a spherical balloon. It's being filled with air at a rate of 200 cm3 per second. Calculate in terms of pi the rate at which the radius is increasing when the radius is 10. Now, whenever you get a connected rate of change question, look at the words. You have to look at the words to figure out what is given to you. Now, you have a formula for volume of a sphere. A sphere is a ball. And they said that the volume, right, so this 200 cm3 per second here is actually dv dt, right? So you have to look at the question and see what is being given. Now they want you to calculate in terms of pi. So the question is asking you to calculate the rate at which the radius is increasing. So this here is dr dt, right? That's what they want. They want dr dt. So here's what you're going to do. The first thing I would do here is to write down a connected rate of change formula in order to find dr dt in terms of this, right? So therefore, I can work out dr dv multiplied by dv dt, right? Now, what is happening here, I don't want you all to think of these things canceling, right? But look at the dv's, right? The dv's, they're going to disappear and you're going to end up with dr dt. So how are we going to do this, right? So the first thing, we know that the volume is given by 4/3 pi r cubed, right? That's the volume of a sphere. So I would work out dv dr, right? dv dr will be 4 pi r squared, right? And we know that r, in the question, it told you that r is 10. So you're going to say when r is equal to 10, your dv dr, right, is equal to 4 multiplied by pi multiplied by 10 squared. So that's 10 squared is 100, 100 by 4. So this is 400 pi. They want the answer in terms of pi. So we're just going to leave it as that, right? Also, we know that dv dt is equal to 200, right? So therefore, all I need to do is to plug in here. Now the thing is, they want dr dv here, right? So this here, this 400 pi is actually dv dr. So you're going to invert this. So this is going to be 1 over 400 pi multiplied by dv dt, which is 200. So therefore, this is going to be 200, right, over 400 pi, right? So these zeros will cancel, right? So this will just be 1 over 2 pi, right? And this is dr dt, so that's the radius. So this is going to be cm s to the minus 1, right? I know some of you all might be watching this and thinking, wow, what is this by? right? So this is what we call connected rates of change, right? So like I said, question 1, right? I give you the list of formulas you need to be familiar with, right? These are the formulas we need to know, right? See what else I have here. Oh, okay. So this is also important, right? So kinematics can come in question 4 or question 5 or both, right? And there are certain things you need to know when it comes to kinematics, right? So let's start with, if I have displacement, right? Normally it's represented by an S. So this here is displacement. Now, if you have displacement and you want to figure out what is velocity, right? What you need to do is to differentiate your displacement, right? So when you have displacement and you want to find velocity, we are going to differentiate your displacement, right? If you have your velocity and you want to get acceleration, right? All you need to do is to differentiate your velocity, right? So acceleration is given by dv dt. So that's one possible way they can bring questions. They can give you displacement, ask you to find velocity. Then if you want acceleration, we need to differentiate your velocity. Also, if I want to go in the reverse direction, let's say you have acceleration and you want to get velocity. If you need velocity, then all I need to do, I have to integrate your acceleration with respect to time, right? So if I want to go from acceleration to velocity, we have to integrate. And if I want to go from velocity to displacement, right? Displacement is going to be the integral of your velocity, right? So that's important, right? They like to bring this, right? They like to bring this in the exam. All right. I know I've seen a lot of questions in the chat, but there's a lot to look at, right? So let's have a look at this question here. So a particle moves in a straight line so that t seconds after passing through a fixed point O, the acceleration is given by that formula here. The particle has a velocity of 4 meters per second when t is equal to 2, and its displacement from O is 6 meters, right, when t is equal to 2. All right, so here's what I want. The first part, they want the velocity when t is equal to 2. So this is part 1. So I have acceleration is given by 3t minus 1. And if you want to work out your velocity, I have to integrate this. So this is going to be the integral of 3t minus 1 dt. So when I integrate 3t, I'll get 3t squared all over 2 minus t plus c. Now this is a common mistake students make, right? When they're doing kinematics question, they forget to include the constant, right? So please, you must include the constant every time you integrate, right? Now the question wants the velocity when t is equal to 4. But the thing is, I don't know what c is, right? But what I'm going to do, I'm going to use some information that they have here. They said the particle has a velocity of 4 when t is equal to 2, right? So we're going to use that. We're going to say when t is equal to 2, right? Your velocity is equal to 4, right? So we're just going to plug that information into this. So this is going to be 4 is equal to 3 multiplied by 2 squared, divided by 2, sorry, right? Minus 2 plus c. Now this seems very trivial, right? But could you all work out c for me? I see students, I see students having trouble with this. Right? Could you all work out the value of c for me? Right? For those of you locked in here, right? Keep in mind this is CSEC Ad Maths, right? This is not CSEC Maths, right? This is CSEC Ad Maths, not Maths, right? Right, I've seen people getting 0. Is that really true? I don't know. Let me see. All right, so this is 4 here, right? This is going to be 2 2s are 4, 3s are 12. 12 divided by 2 is 6, minus 2 plus c. Yeah, so c is going to be 0, right? Yeah, that's correct, right? So therefore, that means your velocity equation is given by 3t squared all over 2 minus t, right? Now the question wants to know what is the velocity when t is equal to 4. So you're going to say when t is equal to 4, right, your velocity is simply going to be 3 multiplied by 4 squared all over 2 minus 4. And that's going to give us, that's, what was it, 16 over 2, 8, 3, 24. Oh, this is going to be 20. Right, that's going to be 20 meters per second, right? Right, so that's part one, right? Part two, we want to work out the displacement of the particle from O when t is equal to 3, right? So this is a fairly okay question here. So you know your velocity equation, right? The velocity equation is given by 3t squared over 2 minus. So this here is your velocity equation, right? So if you want to get displacement, right? Displacement is the integral of 3t squared over 2 minus t dt, right? Again, you need to be careful when you're integrating here. So when I integrate 3t squared over 2, that's going to be 3t cubed, right, over 6 minus t squared over 2 plus c, right? So all I'm doing, for those of you not sure what I'm doing here, when you integrate when you integrate x to the power n, right, what is going to happen, we're going to use this formula here. X to the power n plus 1 over n plus 1 plus c, right? That's what I'm using to integrate this, right? So that's where the t cube came from, and the 3 is going to be at the bottom, but you have this 2 here, so it'll be 6, right? So this is my displacement formula. Again, make sure and include your constant here. So you need to figure out the constant, and usually they will give us information that will help us do that. So they said your displacement is 6 when t is equal to 2, right? So when t is equal to 2, right, your displacement is equal to 6, right? That's what I said, right? Yeah, right? So we're going to use that information to figure out our c. So 6 is equal to 3 by 2 cubed, right, all over 6 minus t squared, which in this case is 2 squared all over 2 plus c, right? Could you all work out c again for me? Right? Like I said, I keep seeing students, they're unable to work out a constant, right? Right? So I've seen some people getting 2, some people getting 4 minus 4, right? All right. So like I said, I've seen students struggle to work this out, right? So this here is going to be 6, right? 2 cubed is 8. 8 3s are 24. So this is going to be 4, right? Minus 2 2s are 4 over 2. That's going to be, something wrong here. I'm looking right. Right, so that's 24. Okay, right. Now this makes a little more sense here, right? All right, so therefore we're gonna have 6 is equal to 2 plus c. So therefore c is equal to 6 minus 2, right? So therefore c is 4, right? So be careful when you're working this thing out. So therefore your displacement formula is given by, right? Now 3t cubed over 6 is actually t cubed, right, over 2, right, minus t squared over 2 plus c, right? So we're just going to plug in, the question asks us to work out the displacement when t is equal to 3. So you're just going to plug t into this, t is equal to 3 into this formula, right? So therefore s is equal to 3 cubed over 2 minus 3 squared over 2, right? C was 4, right? C was 4. right? So what is that displacement there? What are you getting? Try to work out the displacement there for me. Right, we're getting 13, right? So that's going to be 27 over 2 minus 9 over 2 plus 4, right? And you're going to get 13, right? And this is displacement here, so this is 13 meters, right? Now, let me just give you all the formulas that we need to know for integration, right? So when you integrate x to the power n dx, you're going to get x to the power n plus 1 all over n plus 1 plus c, right? That's one form of integration that we need to be familiar with. When you integrate something like a constant, right, you're going to get kx plus c, right? If I integrate, so there's an integration formula that looks like this, ax plus b to the power n dx, right? When I integrate this, I'm going to get ax plus b to the power n plus 1 all over a by n plus 1. You all need to know this formula. Some of these formulas, like I said, they're not given to you in the exam. You have to know them. If you integrate cosine x dx, you're going to get sine x plus c, right? If I were to integrate cosine ax, right, you're going to get 1 over a sine ax plus c, right? So you need to know that formula. We could have integral of sine x as well. So the integral of sine x dx is going to be equal to negative cosine x plus c. And then we also have integral of sine ax. And in this case here, we're going to get negative 1 over a cosine ax plus c, right? So these are integral formulas that we need to know for the exam, right? So just be aware of that. Right, what else do I have here? All right, so one of the things that we could be asked in the exam is to find volume of revolution, right? So when it comes to integration, we can apply integration to do certain things. So one of the things we can use integration for is to find the area under a curve. Let's say this is A and this is B, and I want to find that area here, right? And this is a curve given by this here. If I want to work out the area, that area is given between B and E of whatever that equation of that curve is, right? That's how we find the area under a curve. If, however, I were to take that area, right? If I were to take this area here, and I were to rotate this area, right, around the x-axis by 360 degrees, I'm going to sweep out a particular volume, right? In which case the volume is given by pi times the integral between b and e, and you have to square the function dx, right? So this formula here, right? Some students might make a mistake when you're using a formula like that. So if we have to do a question like this is the equation of the curve, right? These are your limits, 0 and 1, and you want to work out the volume of this thing here. So the first thing you'll do in a question like this, we have y is equal to x squared plus 1. The first thing I would do is to make sure I know what y squared is, right? So we're going to square this. This is x squared plus 1, and you need to square this, right? Now, when you square this here, this is going to be x to the power 4 plus 2x squared plus 1, right? That is what I'm going to get when I square this. So if I want to work out the volume, right, of this solid that we're going to get, it's going to be the pi times the integral between 1 and 0 right? And the curve is given by, or the square of the curve is given by x fourth 2x squared plus 1 dx, right? So this is considered what we call a definite integral. So with respect to volume, don't touch the pi, leave the pi right here, right? First step is to integrate. This is going to be x to the fifth over 5, right? Plus, this will be 2x cubed all over 3, plus this constant here. When I integrate that, right, you're going to get x. We're not going to put a c here because this is a definite integral, so we're going to ignore that. So we're going from 1 to 0. So again, all you're going to do, you're going to say pi, right? And we're going to substitute 1 into the formula. So that's 1 to the fifth over 5 plus 2 by 1 cube all over 3 plus 1, right? So you substituted the 1 into your integral minus, open brackets, you're going to substitute 0 now. So this is 0 to the power 5 over 5 plus 2, 0 cube, right? All over 3 plus 0, right? Close brackets. So now, we still have the pi on the outside here, right? Now this whole thing here, when you work this out, it'll be 0, right? Now be careful. Sometimes it may not work out to 0, so just be careful. So this is going to be 1/5 plus 2/3 plus 1, right? So in this case here, we're just going to use our calculator. 1/5 plus 2/3 plus 1, right? And you're going to get 28 over 15. So this here is going to be 28 pi over 15. And since it's volume, it's going to be units cube, right? Now guys, make sure, right? Make sure and walk with a calculator in the exam tomorrow, right? Make sure you walk with a calculator tomorrow. Whether it's a calculator like what I have here, Sharp, right? Or the Casio, just make sure and walk with a calculator. You cannot go into that AdMaths exam without a calculator, right? Yeah, some of you all give me the answers in decimals. You can if you want as well, right? But typically, CSEC may tell you. So the question says actually in terms of pi, right? It says in terms of pi. So make sure you put the answer in terms of pi, right? All right. So I'm going to make a little switch here, right? So the last question in the exam, some of you all could get some marks, right? Let's have a look at this question here, right? So one of the things that they like to bring either stem and leaf diagrams, or they can bring something called a box and whisker plot, right? So we have some data here, right? Use the data set provided to answer the following questions. So one of the things you have to pay attention to, because CSEC are a little tricky sometimes, they might give you data, but the data is not in ascending order, right? That's something you have to watch out for, right? Make sure the data is in ascending order. If it's not, then you're going to have to put it in order, right? So the first part, we want to construct a stem and leaf diagram for this, right? So when you look at the data and you want to construct a stem and leaf, look at the smallest data and then look at the largest data, right? So you're going from 15 to 75, right? So let me get I want a blank sheet here. All right, it's a very common question as well, right? All right, so we have some data here, right? So you want to draw what we call a stem and leaf diagram. So you have your stem and you also have your leaf, right? So you're looking at the smallest number, you have 1, right? But you're going on to 7, right? So 1, 2, 3, 4, 5, 6, and 7, right? Now again, use rulers when you're doing this, right? So we have a stem and leaf here, right? So we start with the numbers. We have 15, 16, 18, 18, 20. So we put a 5 here for the 15, 6, we have 8, and we have 8, right? So we take care of this, right? Always make sure you're taking care of all the numbers, please. Then we have 20. So we put a 0 here. Then we have 21. We have a 22. We have a 22. We have a next 22. Right? Then we have a 25. Right? Then we have a 28. Right? Then we switch to 30. We have a next 30. We have 32. We have 35. We have, that's it, right? 1, 2, 3, 4. Then we have 40. 41. Then we jump to 52. Right? And then we have a 54. Then we have a 59. Then we have a 60. We have a 65. We have a 68. And then we have a 75. Right? So what I normally do, I check to see how much data we have first of all. So that's 1, 2, 3, 4, 5, 6, 7, 8. 8 trees are 24. Right? So we have a total of 24 in this case here. Right? Now, let's make sure we have that on the stem and leaf diagram. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yeah, we're good there, right? So this is your stem and leaf diagram here. But please, when it comes to stem and leaf, remember you have to put a key, right? So the key in this case, let's put 1/5, right? And that means 15, right? So make sure and put that on your diagram, right? So don't forget the key, right? Don't forget the key. Right? So now here's what's happening here, right? So the first part was to construct the stem and leaf. We did that, right? Part 2, state the advantage of using a stem and leaf diagram to represent the given data, right? So I know some of my students in this live here. What's the answer for this here? State the advantage of using a stem and leaf, right? For your exam, you need to know the advantages of using a stem and leaf, and you need to know the advantages of using a box and whisker plot, right? Right, so people saying the correct thing. All the raw data is maintained, right? When it comes to a stem and leaf diagram, so if you all want to get an easy 1 mark in the exam, right, make sure you know at least one advantage of the stem and leaf diagram. Basically, all your raw data is preserved. This is the raw data here, right? But when I go to the stem and leaf diagram, I still am able to determine all the raw data. It is still there, right? So that's one, right? Now, this is where things get a little tricky for some students here. Could you all look at that data for me, right? Look at it from here if you want. What is the mode? I know it's looking simple, but I see people getting this wrong. What is the mode? Watch your data. What is the mode? Right, people saying 22, some people just guessing, right? So the mode is the one that occurs most frequently, right? If you look at the data, you have a 22, a 22, and a 22. So I would say that the mode is actually equal to 22, right? So from statistics, mode is the one that occurs most frequently, right? 22. The next part is this, determine the median, right? The median is the middle. Right? Now, I have seen students struggle with this, right? They learn of a formula in school, but they don't know how to use the formula, right? Could you all tell me what is the median? Look at the data here and tell me what the median is. This is something that we should be getting correct, right? Right? Moderators, Aditya and you guys, if you feel you need to bump off anybody from the chat, if they come here to waste time, just kick them off, right? I don't have time to waste for that. Right? I don't want the formula, you know, because a lot of students, they know the formula, right? And they know the formula, but they just don't know how to use it. I want to know what the answer is. I want to know what the median is. Look at my data here, and I want you to tell me the median. I don't want any formula, right? Because lots of students, right? I see a lot of students coming by me, and they're using that formula, and they still get any question wrong. Right? All right, so some people saying 29, some people saying 30, right? So let's see what is the answer here, right? Right, the moderators you all seen in the chat, those are some of my students who are in my class, right? So anybody here to waste time, just kick them out, right? Right, so determine the median, right? So the median, so like I said, the first thing we do, we check to see how many, right? How many students or how many data points we have. We have a total of 24, right? Now, usually I will draw a diagram like this, right? So n is 24. Right? Now I do the same thing for normal CSEC maths as well. When I have to calculate things like, right? So this here, right? What I do, I draw something like this, right? So I have 1, that's your first data point, and then you have your 24th data point. The next thing I'm going to ask myself, is that number an odd or an even number? That number here is an even number. When it comes to finding the middle of an even data set, there is actually no middle. So what I'll do, I'll draw a line here, right? So my median, right, which is what we call our Q2, has to be here, right? But there's no exact median. So what I need to do, since we have 24 data points, 24 divided by 2, let's split the data in half. So that's going to be 12. So therefore, the lower half of the data goes from 1 to the 12th, right? And then the upper half of the data goes from the 13th to the 24th, right? So now, all I need to do is to go to the table and I need to figure out what is the 12 data point and what is the 13 data point. So let's go to this here, right? And we're going to check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that is actually 30. So this here corresponds to 30. And the one right after also is 30, right? So therefore, this here is 30 as well. So therefore, your Q2 or your median is found by taking the 30, add it to the 30, right? And divide by 2. And that's going to give you 30 as your median, right? Hope that making sense, right? This diagram is very helpful when you're trying to work out this, right? So there's no exact middle. So I need to figure out what is my 12th and 13th data set, right? So that's Q2, right? That's your median. So this here is 30. The next part, we want to calculate the interquartile range. Again, that's problematic for some students, right? So interquartile range, right, is equal to your upper quartile minus the lower quartile, right? That's interquartile range. CSEC could potentially ask us about semi-interquartile range as well, right? Which is simply going to be a half multiplied by Q3 minus Q1, right? So let's start. The first thing we need to do, we need to figure out what is Q1, right? So I want you all to look at the data and I want you all to write down for me what you think Q1 is. Look at the data carefully. We need to figure out what is Q1. I'll give you 2 minutes here to figure it out. What is Q1? I see many people begging for trigs, right? Some people begging for logs, right? Right? Some people saying 21 is the answer. Some people saying 21.5 is the answer, right? Now let's look at the data again. So from the 1st to the 12th, that's from here to here, right? That is 12 data points, right? Again, that's an even number, right? So when we have even data set, that's when problems start, right? So there's no exact middle again, right? To get the Q1. So Q1 is this green line here. So therefore, I need to figure out, right? So we're talking about 12 data points here. So this is the 6th and this is the 7th, right? On either side of that Q1 there. So I need to figure out what is the 7th value and what is the 6th value and the 7th value. again, you go to the table. So 1, 2, 3, 4, 5, 6. So that's 21 and 22, right? Those are the two numbers you're looking for. So this is 21 and this here is 22. So therefore, your Q1 is going to be 21 plus 22 divided by 2. And therefore, that's going to be 21.5, right? 21.5, right? So you all are correct, right? You all actually worked it out properly, right? We do the same thing now for Q3, which is the upper quartile, right? So Q3 in this case here, if you look at the upper half of the data, again, you have an even data set, right? So from here, from 13th to 24th, that's an even data set. So again, there's no exact middle, right? Because that is actually 12 data points there. So therefore, your upper quartile, let's put a line here to represent the upper quartile. So this here is your Q3. And we need to figure out what is this one and what is this one here. Now, this is where things get a little tricky, right? Some students, they can't figure out what terms or which one are we looking for, right? Now, if this is your first, right, and this here is your sixth, it means you added 5. So if this is 13, we're going to add 5 to this. So this is 18th. So we're looking for the 18th and we're looking for the 19th. That's what we're looking for, right? So you have to go to the table and figure out 18 and 19. So let's go to the table. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So that's 52 and 54, right? 52 and 54. So this here is 52 and this here is 54. So you're going to use those two numbers to get Q3. So this is going to be 52 plus 54. Right, all over 2, and this will work out to 53, right? Right, so to work out your interquartile range, all we need to do is to take the 53 minus the 21.5. You're going to get 31.5, right? So 31.5 here is your interquartile range, right? If you want to get the semi-interquartile range, just divide that answer by 2 and you're going to get 15.75, right? So those are things that come in the exam, right? Just, draw a box and whisker plot, right? In this case here. A stem-and-leaf diagram, right? So you worked out the interquartile range. But there have been questions where they made them draw the stem and leaf diagram, and then from that now they are able to construct a box and whisker plot, right? Now if you are asked to draw a box and whisker plot, there are 5 numbers that you need in order to do that, right? So this is what you call a box and whisker plot. Right? A box and whisker plot, we need to know the minimum, right? We need to know Q1, that's the lower quartile. We need to know the median, which is Q2. We need to know what is the upper quartile, which is Q3. And you need to know the max, right? So a box and whisker plot, all you need are 5 numbers in order to do that. So go to the table. Your minimum is 15 and your maximum is 75. So this is 15, this is 75, right? We also worked out Q1, Q2, and Q3. Q1 was 21.5, then 30. This is 21.5. This is 30, right? And the last Q3 was 53. Now, I generally have an issue with when CSEC asks us to plot a box and whisker, right? Because, I saw I spelled whisker wrong, yes. Sometimes they want us to comment on the data, comment on the skewness of the data, right? So what I would suggest you do, right, since they're not giving us graph paper to plot this thing here, right, you're going to take your pencil and I would do this, right? I will draw some lines, right? Light lines here. So that's 15, right? Let's say 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, right? And let's try to fit everything in. So this is 15, right? 20, 25, 30, 35, 40. Right? So you're doing this in pencil here. So you want to kind of get a realistic box and whisker plot, right? So the first thing I will do, I'll draw the minimum. So the minimum, you're going to draw a line here, right? At 15, the maximum is 75. So you're going to draw a line here, right? Sorry, let me just draw this a little neater. Right? So around there. So we drew this, right? Q1 is 21.5. So you're going to estimate now, right? 21.5 is somewhere about here. Right, so that takes care of that. Q2 is 30, right? So you're going to draw a line here. So that's Q2. And then Q3 is 53. So that's somewhere about maybe here, right? So now I have all the information here in order for me to plot a box and whisker. So you're going to draw a line here, right? The median was what, 30? So we're going from here. Right, and then the last one here is going to be this, right? So this here is your box and whisker. Now I just letting you know, CXC expects certain things. You need to label this as your min, but you have to put in the 15. You're going to label this as your Q1, and you're going to have to label this here as well, right? Label this value here. That value is 21.5. You need to label that, right? Q2 was 30, so this is Q2, right? So you're labeling that as well. And your Q3 was 53, right? So you need to label this as well. This is 53, right? And then this here is your max, and the max here corresponds to 75, right? So this is what your box and whisker plot is going to look like, right? But let me ask a question. CXC may make us plot the box and whisker, and they may ask us what is the disadvantage of using a box and whisker plot. Anybody know the disadvantage? What is the disadvantage of using a box and whisker plot? Yes, you can draw this diagram in pencil, right? You can draw that diagram in pencil, right? Right, so people say the raw data is not preserved. Yes, when it comes to this diagram here, the raw data is gone. I can't calculate your mean, I can't calculate standard deviation, that's it, it's gone, right? But there is an advantage, right? You can easily compare two sets of data. If you have the box and whisker plots, you can put them side by side and you can compare them, right? Let me ask a question. I saw some of you all answer it already. Wow. If you were asked a comment on the skewness of this data, what you'll see? What can we say about the skewness of this data here? Right, somebody's asking about a scale. Yeah, that's what I just did there. I basically, right, I basically kind of estimated, right, draw lines in pencils so that you can actually sketch this thing realistically. Because usually when they make you sketch this, the next thing they're going to ask you about the skewness of the data, right? Now everybody's saying the data is positively skewed. Yeah, I agree. So the data is positively skewed. Always justify your answer, right? Always justify your answer when you say it is positively skewed or negatively skewed. I agree it's positive, and here's my reasoning. My reasoning here is this: that spacing Q3 minus Q2 is greater than the spacing Q2 minus Q1, right? That's my justification. So if this piece here, from here to here, if that piece is bigger than this piece here, then it's positively skewed. If it's reverse, it's negatively skewed. So I normally look at Q1, Q2, and Q3, because sometimes when you look at the whisker, right, you might get a different interpretation. So I will always justify, and I will tell them why I'm saying that, based on the spacing between the Q3, Q2, and Q2, Q1. That's typically what I do, right? right? Somebody's asking about pencil. Guys, please do your exam in pen. If you have to draw a diagram, you can do it in pencil, but make sure and write in pen, right? Right? Right, so that's that there, right? So you can get a box and whisker and you can get a stem and leaf, right? I'm just gonna do one more thing here. So probability is something that we know we're gonna get in the exam, right? It could be something very simple. It could be in the form of a pie chart, right? Not pie chart, sorry, in the form of a Venn diagram, right? So it can be in the form of a Venn diagram. It could also be in the form of a probability tree diagram, right? Which is typically straightforward for the most part, right? I've had students ask me about how many branches. So your syllabus says 2 branches only. So don't expect a probability tree diagram with 3 branches. It'll only be 2. So there is, let's look at this thing here. 2 events, A and B, are such that P of A is 0.5, P of B is 0.8, and PA union B is 0.9. The first thing we want to calculate is probability of A intersect B, right? Now in terms of a Venn diagram, right, if I have 2 events A and I have an event B, what they're really asking me for here is what is this probability here, right? So there is a probability formula that you all need to know. So that is probability of A union B, right, is equal to P of A plus P of B minus probability of A intersect B, right? So we want to work out PA intersect B. So PA intersect B, right, is equal to P of A, right, plus P of B minus P of A union B, right? So in this case here, it is going to be 0.8 plus, sorry, 0.5 plus 0.8 minus 0.9. So that's 0.5 plus 0.8 minus 0.9, and you're going to get 0.4, right? So that's the answer for the first part, right? PA intersect B. The second part here is a conditional probability. Whenever you all see this vertical line here, that's a conditional probability. So probability of A given B, right? And that's something you need to look for to know if it's a conditional. You'll see this word here, given, right? That'll tell us it's a conditional probability. So the probability of A given B, that's also a formula. That's A intersect B all over the probability of B in this case here. So A intersect B is 0.4, right? And probability of B is 0.8, right? So that's going to be 0.5, right? So that's the conditional probability A given B, right? All right, somebody's talking about, yeah, so that's one of the reasons why I try not to write in pencil, right? All the papers are supposed to be scanned, right, before it is marked. So if you write in pencil and they scan it and you can't see, that's a problem, right? All right, so that is A given B. The next part here, right? CSEC can ask us, state given a reason whether or not A and B are independent events. Whenever you are asked to show this, right, or to determine if 2 events are independent, this is what you need to do. The probability of A intersect B has to be equal to the probability of A multiplied by the probability of B. This is something you have to show if the events are independent. If you can show that, great. Now here it is. A intersect B, we just worked that out here. We got 0.4. Now let's calculate A intersect B by using this and by using this. So this here is going to be 0.5 multiplied by 0.8. So that's 8 by 5 is 40. So this is 0.4, right? So you realize, wait a minute. A intersect B, probability of A intersect B is equal to this, right? Since they are equal, they are considered independent events, right? So look out for those words. Whenever we see independent events, this statement here has to hold true. Probability of A intersect B must equal to the probability of A plus the probability of B, right? We also have something called mutually exclusive events. So CXC could ask us about this as well. Mutually exclusive events. Right? So mutually exclusive events look like this. You'll have an event A and you'll have an event B, but the two circles, they're not going to intersect on event diagram. So what happens if we end up with a probability like this, A intersect B is equal to 0, right? Then those two events are mutually exclusive. And what happens as well is that the probability formula changes. It becomes P of A plus P of B, right? So this is for mutually exclusive events, right? All right. So like I said, right, I just had some time. I decided to come online, right? But keep in mind that I'm not going through the entire syllabus, right? I did that. I had my session a little while ago, right? 2 Saturdays ago. All right. Let's see what else I had here for you guys, right? Just so. Right. So let's look at this question here. Right? CXC like to bring this quadratic function. Actually, I'm gonna do this one first. Right? Let's do this one first. Right? Almost every year we get something on completing the square or some kind of quadratic. So I have a quadratic here, and I want to write it in this format. Right? Now this question could easily come in your normal CSEC maths. Right? Now some of you all have learned off your formulas, and that's fine. Whatever method you want to do to complete the square, that's great. Right? Just remember how to do it. So I have 3x squared, right, minus 9x, right, plus 4, and I want to complete the square, right? So for me, this is what I would have taught my class. The first thing we do is factor out this 3 here. So this becomes x squared, right, minus 3x plus 4 over 3, right? So the first thing I do, I factor out that 3 there. Next thing we're going to do, right, now if you never did this method, don't worry about it. Stick to what you know, right? So this here is going to be x minus, we're going to find half of this here. So this is going to be 3 over 2. Right? We're going to square that. Right? You're going to write back the term from above, which is 4 over 3. And you're going to minus this term here squared. So if I square 3 over 2, I'm going to get 9 over 4. Right? Again, if you've never seen this before, do not worry about it. Stick to what you know. Right? So this is x minus 3 over 2 squared. Right? And 4 over 3 minus 9 over 4. And I'm getting minus 11 over 12. Right? And then the final step now is to multiply by 3. So this becomes 3 by x minus 3 over 2 squared. Right? Minus 33 over 12. Right? For those of you who have your other methods, right, you could just double check my answer, make sure it's okay. Yeah, so I see some of you all put any formula in the chat. So if you all know that formula and you're okay with it, sure, go ahead, right? Right, just now, let me just make sure I've seen some answers in the chat here. Let me double check my answer. So we factor out 3 first, right? So somebody's asking me I got 9 over 4. You have to square this 3 over 2 here, right? When you square 3 over 2, you get 9 over 4, right? Oh yeah, well the 33, okay, right, sorry. This could reduce, right? This could reduce here. So let me just reduce it one time, right? I was wondering if I wrote something wrong. So yeah, this could be reduced to 11 over 4. Yep, that's true. All right, let me just see something here. right? So, okay, so a lot of people getting negative, so just double check your answer, right? I'm getting negative here, right? Now they like to bring this. Say the coordinates of the minimum point, right? So again, this is something we can get in normal maths, right? So to get the coordinates of the minimum point, the first thing we do, we put this bracket piece here equal to 0. So therefore, x is equal to 3 over 2, right? So that's the x coordinate of the minimum point, right? So the min point is simply going to be, right, 3 over 2, right? And we're using this value here, this minus 11 over 4, right? So this here is minus 11 over 4, right? So that's your min point. They like to bring this. All right, let's go back to this root question here now, right? So they gave us a quadratic equation, right? Given by 3x squared minus 6x minus 4 is equal to 0, right? Now there's several things they can ask us. They can ask us to find the discriminant, which is given by this formula here. B squared minus 4ac, right? That's our discriminant, right? But in this case here, they're telling us that the roots are alpha and beta, right? And they want us to figure out what is this here, 1 over alpha plus 1 over beta. So the first thing I would do, I'll compare this to ax squared plus bx plus c, right? So therefore a is equal to 3, right? B is equal to minus 6, and c is equal to minus 4, right? That's step 1. I need to figure out these things here. Now, since the roots are alpha and beta, let's work out alpha plus beta. So let's work out the sum of the roots, right? Could you all put in the chat, what's the formula for the sum of the roots? What's the formula, right? All right, one second, I went back here. Let me see something. Alright, so I've seen some of you all give me some wrong formulas here, right? But it is minus b over a, that's the formula. So all I need to do is to plug in minus b, so that's minus 6 all over a, which is 3. So that's positive 6 divided by 3, so that's 2. So the sum of the roots will be 2. The product of the roots alpha beta, right? So some of you all gave the formula there already. It's c over a. So in this case here, it is minus 4 all over a, which is 3. So that's the product of the roots, right? Now they want me to work this out here without actually finding what the roots are, right? So you have to write this here in terms of a sum and product, right? So here's how you're going to do that. Right, so 1 over alpha plus 1 over beta, right? Let's add this first. You're adding two fractions. Your LCM here is going to be alpha beta, right? And therefore, this here is going to be beta plus alpha, right? So when you add these two fractions, that's what you're going to get. So all I need to do is to plug in. So this part here is your sum, and this part here is your product. So the sum, we got that value as being 2. So this is going to be 2 divided by the product, which is minus 4 over 3. Right? So that's going to be 2 divided by minus 4 over 3. Right? And you're going to get minus 3 over 2. Right? So this here, you see this? This is a common thing that they ask us in the exam. Right? Another useful thing that you all should know as well is this. If I want to work out, let's say alpha plus beta squared, right? That is actually given by alpha squared, right? Plus beta squared, sorry. Right? Minus 2 alpha beta, right? So keep this in mind, right? This here, you may need it for an exam question, right? So just be aware of this, right? That's not, I think I have it wrong. Hold on. All right, this is what it is, right? This is what this is here. But what they could ask us to work out is alpha squared plus beta squared, which could be written as alpha right? So there are some questions where you might have to use this, right? If they ask you to work out alpha squared plus beta squared, right? Right? So that's important, right? That's a common thing that they like to bring, right? All right, that's now. Everybody begging for logs and tricks, right? So just now. Now let's have a look at this question here. We have 2 to the power 2x plus 1, right? Plus 5 to the power, 5 multiplied by 2 to the power x plus minus 3 is equal to 0, right? Now, this particular question here, we can reduce this to a quadratic, right? Now, you have to be careful how you're doing this here. So the first thing you're going to do, you have to decide what am I going to substitute. So the substitution I'm going to use here is to let u equal to 2 to the power x, right? Now you can call it y, you can call it whatever you want, right? I'm just calling it u. So we need to tinker with this here. We need to change this up a little bit. This here could be written as 2 to the power 2x. Actually, because I already have space there, I'm going to do it here. 2 to the power 2x plus 1, right? That could be written as 2 to the power 2x multiplied by 2 to the power 1, right? This here could be written as 2 to the power x squared multiplied by 2, right? So I'm going to break this up a little bit here, right? And I'm going to write this as 2 by 2 to the power x squared plus 5 by 2 to the power x minus 3 is equal to 0, right? Now we're going to let u equal to 2 to the power x. So I'll end up with something like this. 2u squared plus 5 multiplied by u minus 3 is equal to 0, right? So what I'm doing here, I'm reducing this equation so that it looks like a quadratic. So let's factorize this. So this is going to be 2u by u is equal to 0, right? Let's put a 1 here. Let's put a 3 here, right? So this will be minus and this will be plus, right? So if I work this out here, I'm going to end up with u equal to half. That's one possibility, right? Or we can get u is equal to minus 3. Now that's not our answers because you made a substitution, right? So what you're going to do now, you're going to say, let's put the first one here, 2 to the power x is equal to a half. So therefore, 2 to the power x is equal to 2 to the power minus 1. So therefore, x is equal to minus 1. So this is one solution. The second thing here now, we're going to put 2 to the power x, right, is equal to minus 3, right? But if I try to solve a question like this, if I have to solve an equation like this, you're going to take logs on both sides. However, if you try to work out the log of a negative number, you're going to get an error. So if you all try to find log of negative 3, you're going to get an error. So this has no solution here, right? This has no solution. So look out for things like that in the exam, right? One second, I'm just trying to get, I know a lot of people were asking about trigs. So, right, let's do this trigs here. Right? So now, you could be given a question like this, right? To solve an equation like this, right? Yeah, factorizing. Somebody asked about factorizing so fast. So that's years of practice, right? Years of practice, right? Okay, so you want to solve this here, right? 8 sine squared theta, right, is equal to 5 minus 10 cos theta, right? Now this equation here, right, is in the form in such a way that I can't solve it as yet, right? And what I'm going to use, I'm going to make use of this identity here. Sine squared theta plus cos squared theta equal 1, right? So in this case here, we're going to make a replacement here. We're going to substitute sine squared into this. So sine squared theta is equal to 1 minus cos squared theta, right? So that's sine squared. So what we're going to do, we're going to replace this here, right? I'm going to replace this. So this is going to be 8 by 1 minus cos squared theta, right, is equal to 5 minus 10 cos theta, right? So let's remove the brackets. So this is going to be 8 minus 8 cos squared theta, right? And this is going to be 5 minus 10 cos theta, right? Now I don't like to have a negative in front of my squared too, right? So what I'm going to do, I'm going to carry everything to the right hand side. So this is going to be 0 is equal to 8 cos squared theta, right, minus 10 cos theta, right, plus 5 minus 8, right? So therefore 0 is equal to 8 cos squared theta minus 10 cos theta, right? 5 minus 8 is minus 3. Now there are some students who could just watch this and factorize this, and if you can, great, right? Kudos to you, right? But what I would suggest is let u equal to cos x, right? This will help you see it a little clearer, right? So in this case here, let's write it as 8u squared minus 10u minus 3 is equal to 0, right? And then we're going to factorize this, right? Let me give you a chance to factorize this one here. Tell me what you're getting when you factorize this. Somebody said I forgot the theta. Let me see where. Oh, yeah, my bad. Alright, I'm trying to write fast. Thanks. Alright, so I've seen some people work it out already, right? They actually worked out what u is, right? So let's see. If I put 4u here and u here, right? Let's say if I put 1 here and maybe 3 here. All right, so I want to get, that's all. Right, let's see if that's correct or not, right? So I'm kind of using trial and error here, right? So 4 by 2, I'll get 8u squared, right? I need to get minus 3, 4 3 12, minus plus. Will that work? All right, let's see those numbers. 4u by 2u, you get 8u squared. Minus 1 by 3, you get minus 3. 4 by 3 is 12. No, it's the other way around. Right, this should work out now. Right, so minus 12u plus, okay, so this is correct here, right? So you're going to get, if I put each bracket equal to 0 here, I'm going to get that u is equal to negative a quarter, right? And the second one here is that u is equal to 3 over 2, right? Right, so negative a quarter, 3 over u, right? Now, what am I going to do with that? So this part is the tricky part here, right? That students have a little trouble with, right? So a good thing we're doing this question here. One second, I'll lose the question. Right here. Okay, so what do we have? We have u is equal to minus a quarter. So therefore, cos x is equal to minus a quarter. Right? And we also have that cos x is equal to 3 over 2. Right? Let's start with the easy one first here. Right? So this here is actually 1.5. Right? So if I try to work this out here, I'm going to get no solution, right? I'm not going to get a solution. How do we know this? Well, you all need to know for the exam how to sketch sine x, cosine x, right? So this is y, this is x, right? Cosine x looks like this, right? This is positive 1, this is negative 1. So cosine does not exceed positive 1 or negative 1, right? This here is 360. Right? This here corresponds to 180. So you all need to be able to sketch these graphs, right? So as you can see, our graph doesn't go beyond 1. So therefore, you can't get a solution for this. Now, cosine x is equal to negative a quarter. Now, this here is important, right? So you need to be aware of your quadrants. So we have all school teachers costs, right? So this tells me which ratio is positive in which quadrant. Now, the thing is, cosine is negative in this case here, right? This sign here is negative. So if you look at the diagram here, you will know that cosine is only negative in the second quadrant and in the third quadrant, right? So here's what's happening. So the first thing I'll do, I'll find my principal value. So let's work with cosine x is equal to a quarter. And let's work out this angle here, right? So you're going to use your calculator to figure out this angle, second function cosine 0.25. You're going to get about 75.5. Right? When you're working out your angles, work them to 1 decimal place, not 2 decimal places. Right? CSEC might actually tell you to the nearest degree, right? But I typically work to 1 decimal place. Now this answer here is not my answer, right? That's not the answer, right? Yeah, somebody said, use all school teachers care. That's a good one, right? That's a good one. This was told to me since Form 3, right? So this was like many, many years ago. A teacher told us this, right? That's a good one though, right? So anyway, let's work out the angles, right? So we know that the first angle, right, has to be in this quadrant here, right? Now let's label this quadrant here, 0, 90, 180, 270, right? So the thing is, the angle that we need to work out is this angle here. How do we get that angle? Well, that angle is always related to the angle in the first quadrant. So you see that 75.5 that we got here? That is what this angle is here. So if I want to work out this solution, it'll be 180 degrees minus 75.5. And you're going to get 104.5, right? 104.5, right? So that's the first answer. So x is equal to 104.5, right? The next thing, we have to work out the third quadrant angle. So the third quadrant angle in this case here, right, is going to be down here. So the angle we're looking for is this angle. So again, label 0, 90, 180, all right, 270, right? So to get this angle here now, remember your angle in any other quadrant is related to the first quadrant. So that 75.5 is actually here. So therefore the actual angle that we're looking for will be 180 plus 75.5. right? And you're going to get 255.5. Right? Now, I know you all have the fancy Casio calculator to work it out, right? But you still need to show your working, right? You still have to show your working. You can use it to double check your answer, right? All right, so people are asking, okay, so this is something you have to be careful with, guys. On your calculator, make sure, depending on, so in this question here, let me go back here. They usually tell you something here, right? So once they tell you something like this, you are working in degrees. If, however, you saw something like this, x is less than or equal to, sorry, theta, right? And you see 2 pi here. If you all see this in the exam, it means you're working in radians, right? Now for me, I like to work in degrees for everything, right? If I need to convert to radians, I'll do the conversion, right? Because you see, if you switch to radians in the exam and you forget to switch it back and you have a question further down the road, you might make a mistake, right? So you have to be careful, right? You have to be careful, right? Right? Now I know some people were asking about logs, right? Let me just tell you something here when it comes to logs. So for logs, you all need to remember your rules for logs. So log to base b of a plus log to base b of b, right? If I'm adding 2 logs with the same base, then you can write this as log to base b of a multiplied by b, right? That's the first rule regarding logs. If I have log to base b of a and I'm subtracting log to base b of b, then this is going to be log to base b of a over b, right? That's the second rule for logs. And the third rule for logs is this, log to base b of a to the power n. I can write this as n log to base b of e. Yeah, right? So these are the 3 basic rules for logs that you all need to remember. Also, you have to be able to move from logs to exponent and vice versa. So if you have log to base b of a, and that's equal to n, that is actually in exponent form is b to the power n is equal to a. So you all have to be able to move in this direction, and you have to be able to move in that direction as well, right? So from exponent to that. Another important one that you could use as well, log to base b of b is actually equal to 1, right? What else we have here? Log to base b of 1, right? That answer is going to be 0. These are also important properties when it comes to logs, right? One thing that could be asked to you in the exam is how to take an equation and rearrange it so that you can write it in a linear form. So for example, if I have y is equal to ab to the power x, and I want to write that in a linear form, then what I do, I'm going to take logs on both sides. So log ab to the power x, right? And this here is going to be log y is equal to log of a plus, so you're applying the log rules here, log of b to the power x. So therefore, log y is equal to log of a plus x log b, right? And if you want to write that in a linear form, you can write this as log y is equal to log of b, brackets, x plus log of e, right? Why did I write it like that? Because I want it to look like y is equal to mx plus c, where your gradient m is equal to log of b and your c is equal to log of e, right? Now CSEC can give us a question like this. They can give us data and they can actually make us plot a graph, right? The graph that I need to plot here in order to get a straight line, right? If I plot log of y against x, I'll get a straight line. So this here has to be log of y, this has to be x, and the graph might look like this, right? So you have to go ahead and work out your slope, right? So you might have to actually draw a graph, work out the slope. The slope is equal to log b. The y-intercept is here, and that is actually equal to log of a, right? So you can take an equation, an exponent equation, right? Yeah, I'm hoping, yeah, guys, I'm hoping that they do bring one like this tomorrow. Really hoping, right? If it does, well, it might take you a little time to draw the graph, but let's hope that it doesn't come. So this here is the rules for logs, right, that we need to be familiar with. Somebody was asking about trigonometry itself. So when it comes to trigonometry, guys, there are several formulas that you all need to know, right? And I want you all to know that when it comes to compound angles, right? Let me just find this here. When it comes to compound angles, the formula, right, is actually there, right? Or the trigonometric formulas are there for you guys, eh? So if you find yourself stuck and you're working on a compound angle formula, the formulas are there. It's given to you. This is given to you in the exam, right? So make sure you know how to use it. So if you want to work out sine A plus B, right, then it's going to be sine A cos B. Use the sine on top, right? So these are actually, this here is actually two identities in one. This is two identities in one, and this is also two identities in one, right? So you have to know how to use this in the exam, right? But it's given to you guys, right? It's given to you guys. All right. All right, guys. So I know you all may not want me to leave now, but I do have to, right? I do have to, right? Like I said, my crash course was like 2 Saturdays ago, right? So I just had a little time here, so so have a look at the video. It's recorded. You can go back to the video, right? I just want to wish everybody good luck in the exam tomorrow. Read your questions carefully. Try to show as much working as possible, right? The more working that you have, right? The more working that you have, the better for you, right? Make sure you walk with your calculator, right? Make sure you walk with that, right? But like I said, read the questions carefully. There are certain questions that they bring all the time, right? So hopefully we get a good paper without errors, right? I think some of the CAPE exam papers, they had errors in the paper. So let's hope that ours don't have an error tomorrow, right? I see some people asking about chemistry. So my chemistry crash course was like Saturday gone, right? The only crash course I have left is physics, and that is this Saturday, right? That's the only crash course I have left, and it's this Saturday. It is from 9 o'clock in the morning till 2:30, right? So if anybody hasn't joined that classes yet, right, you can always send me a WhatsApp, right? But guys, again, good luck in the exam tomorrow, right? I can't teach you the entire syllabus today, right? So good luck everybody and take care, right?